Greetings, everybody. Welcome to today's webinar, part of the Transforming Data into Digital Assets webinar series presented by PIMSoft. I am Ryan Bolin, your moderator, and we thank you for joining us and hope you find this webinar informative and valuable. Today, we want to demonstrate Sigmafine capabilities regarding the tracking and tracing of your raw materials used throughout fertilizer production, thus helping you to monitor raw material costs within inventories and products. In this webinar, you will learn how a model-based approach tracks and monitors raw materials and inventories and products, allocates raw material costs for inventories and products, giving you a tangible solution for material traceability. Thank you for your attention. Now it is my great pleasure to introduce our presenters for today, Felicia Moody, PIMSoft's Industry Principal for Fertilizers, and Elena Mola, a Sigmafine Specialist for PIMSoft. Felicia?
Hello. Thank you for joining us online today. I take the opportunity to introduce PIMSoft, our company, to you. Our mission is this: so we are in the business of generating value for our customers by ensuring the accuracy, reliability, and usability of their process and manufacturing data at all times and across the enterprise. Essentially, we are here to add value. Okay, we are using your data, we are improving it, we are conditioning it, we're putting it in context with the aim of bringing improvements to the users, whether they're systems or persons. Now, today you've heard PIMSoft, that's the company. We've been around for a while. We've been here since 1993. Sigmafine started in 1993 with KBC, while PIMSoft started in 1995 as a distributor of the OSI products, and through the years acquired Sigmafine products from OSI Soft. Sigmafine is our flagship product, and today we're going to show you the material tracking of the arm of this product. But let me just let you know that PIMSoft has a presence here in Italy, in the USA, and in India. That's our newest office. The company continues to grow, and not just in having a new locations, but we've recently acquired Omicron, which has expertise in the OSI product customization. So that's the history of PIMSoft ourselves. Sigmafine came to us, as I mentioned, a few years in the early 90s. And we have grown the product. If you're existing customers, you would know that we are now launching the Sigmafine Hub, which is let's say a web version of the software. So let's talk to you today about PIMSoft and in context to fertilizer. Why do we think this software can bring value to fertilizer? Because in fertilizer, we know that there are some issues. The pain points in the next slide. We know you make. You produce based on what people want. We know that your products are cyclic. You make products at different times of year. It varies depending on the country. So that's quite difficult to even do. Inside your production area, the operations area, we know that the data sometimes is limited. It can be unreliable. Sometimes it has poor quality. Sometimes it's just missing. And in fertilizer, everybody uses it as a commodity. You can use many raw materials. You might be choosing them based on availability, based on cost, based on processability. So you've got three things happening that you need to do well every day in every batch, which can be a tall order. And beyond this, we know that let's say at least in Europe, we know that sometimes you are required to state on your product where the material came from. They not just need to say how much NPK there is, but you need to know where this NPK came from. And this is material traceability, taking your raw materials to your product. And if you even have a solution for each of these pillars, somebody wants to see the report connecting all of them, putting them into context. So you can imagine this is quite complex, as you must be facing today. And these 5 points, we think that Sigmafine is a solution that can address each of these 5 pillars. Why do we say that? Sigmafine has the balancing algorithm. And the balancing algorithm is where Sigmafine can connect to your operations data, to your planning data, to your ERP data, and so that everything is consistent and coherent, batch basis, daily basis, monthly basis, eliminating massive material write-off at the end of the month. And traceability, we're talking about material traceability. Sigmafine has another arm of conditioning your data, and this is the tracking arm. And tracking is where today you will see it in context of how you can allocate, you can follow your raw materials to your products. That addresses your traceability need. And you obviously have this reporting. How do you tell everybody you're doing a good job, or how do you spot when you're doing something bad? Sigmafine is not an Excel tool. It is an infrastructure. It is scalable. It can address industries that have 200 assets to industries that have 20,000 assets. We have connectors to ERPs, to files, you name it, we can connect. So Sigmafine, we think that Sigmafine as an infrastructure with the balancing algorithm and the tracking algorithm can be one of your key pillars to using your data effectively. Today, Elena is going to talk to you about NPK. Okay, we're going to be looking at 3 grades of material or processes, very simple. It's a black box approach. The black box considers the granulated dryer, screening, etc. And you have a common recycle, we call it the NPK fines. And you have multiple material source that you are switching and changing to meet your grade based on availability and stocks. So Elena is going to run through this process and show you how you do it. And in the end, you will come back to me and we'll have a quick look at some reports. Back to you, Elena.
Thank you, Velisha. With this part, I'm going to introduce you to the material tracking analysis. Let's take a blending process where you have some input materials that are at first stocked into intermediate tanks and then sent into the final storage via pipeline. The pipeline is initially filled with material A, and the final tank are filled initially with the material A and B, respectively. Let's observe a limited period of time, for example, 1 day, and let's see the material movements that happen during this period. For each movement, we know the source, the destination, the start time, the end time. These should allow us to keep track of the material composition in our tanks. We see that some input material entered the intermediate tanks, and the material composition in the tank has changed in sequence. The first one was initially empty, now it's filled with material A, and the second one was initially filled with material C, but now its composition changed because some other B and D entered the tank. Then the pipeline is both receiving and sending out some material, and we see that the final composition of the final storage tank has changed, as well as the pipeline composition. Tank was initially filled with material A only, while now some other materials entered, and its final composition has changed. So, if we model this process in Sigmafine, we can execute a material tracking analysis in this model in order to get the final composition, not only of the tanks, but also of the movements involved. Sigmafine is a system that provides many analysis plugins. We have the balance plugin and the tracking plugins. Today, we want to focus on the material tracking analysis. And the way it works is very simple. The analysis uses a composition tracking solver that reads all the input quantities in mass or volume and the input materials, and then calculates a reconciled material composition for the flows and the inventories which you are interested in. These results can be used for different scopes. First of all, to keep tracking of the material mixing quantities through your model. Then you can use this information to allocate the cost per product, or to track the material loans in an ownership context, or also to monitor the material packets through your model to avoid contamination or out of specification products. So let me briefly show you how this analysis works. The tracking algorithm considers many information. The first step is to execute the balance. The use of reconciled data yields more effective computation results. And as the composition tracking analysis is fully integrated with the Sigmafine architecture, you can decide, you have the possibility to read this reconciled data from another source analysis, the balance analysis. Alternatively, it's the composition tracking analysis itself that can execute the balance for you. The second step is to collect all the movements that happen in the observed period, each movement with its own start time and end time. And this is important because the analysis periodicity may be daily, for example, if we focus on 1 day period, but the tracking algorithm behind considers all the time slices that happen during the day. Then you decide which elements are part of the calculation. This permits to use, for example, the same Sigmafine model that we use for the balance, with no need to build a new dedicated model just for the tracking analysis. So you can reuse what you already have built for the balance. And in order to calculate the composition of the tank, of the flows and the movements, the algorithm considers the way how the materials are mixed in each inventory, in each point. And this is defined with the mixing models. In case you have inventories that are not directly measured, because sometimes this information is not available, Sigmafine is capable to calculate the inventory based on the surrounding measurements, if the model has enough redundancy. And then the tracking analysis based on these results can calculate the material composition for you. And finally, the algorithm considers the history of consequent phases. So the initial composition of the current day is automatically taken from the previous day. We previously said that the way how the materials are mixed in the model is defined with mixing models. Here we show you the ideal mixing method used by the analysis. The well-mixed method is used for tanks with homogeneous material. The input materials enter are mixed together with the initial inventory, if there is some inventory, and the well-mixed material is then sent out. The buffer method is similar to the well-mixed, but it keeps the input and the output separate. So it is suggested for tanks with an internal baffle. The makeup purge makes the input going directly to the output line, and only the excess is taken from the bulk of the well-mixed tank. If there isn't enough input to supply the required output, then the remaining quantity is supplied by the tank itself. And vice versa, any excess input material is purged to the well-mixed tank. With the first in, first out method, each packet of material comes out in the same order as it went in. No mixing of material, of course, so every packet is kept with its own sequence. And with the last in, first out, each packet of material is removed in the opposite order from when it came into the inventory. There are some optional parameters that you can specify for the analysis calculation. For example, the analysis gives you the possibility to eliminate the components from the results when their quantity becomes not significant for you. For example, 0.0001% may be not relevant for you to count, so you can decide to eliminate, and this elimination is done respecting the conservation of mass. Then you can normalize the composition data with the reconciled data, and this is strongly recommended to avoid the inconsistency. You can choose to exclude some materials from the analysis. And especially in this case, it's recommended to choose the normalization option. And you can even decide to make the analysis calculates the final density and another material quality, material property, based on the composition results. We prepared a demo for you to show a material tracking application for fertilizer industry. We modeled NPK product blending process for different final NPK formulations. Scope of the analysis is to track the daily composition of NPK product and NPK fine pile based on the raw materials which NPK is composed by. And based on these results of the composition, the analysis calculates also the cost of final NPK products and inventory. This permits to see how the material's quantity may impact on the final NPK cost. So we propose a 12-12-12 formulation, then a 5-20-20 formulation, where, for example, the ammonium sulfate is not used. And finally, 17-17-17 formulation, where some fine is recycled back to the process. So let me move to a machine where the Sigmafine material tracking is installed. And let me show you the model that we prepared in Sigmafine. So we have on the left side all the possible input materials that can be used to produce the NPK. Depending on which formulation we want to produce, we may have some active flows or not. For example, for this case that I'm looking at, the 29th of April, we are not using the ammonium nitrate. So it is represented here for other days where we are using it. But in this case, we have the quantity that is equal to 0. Then the raw materials are processed. We have different stages. The granulator stage, where some vapor is sent out to the scrubber. Then the NPK is dried into the drying process. So we have, again, some water that goes out from the model. And finally, the NPK is produced and sent to the particle site separation, to the screen process. From here, we can produce different materials, different formulations of NPK. The case we are looking at, the 29th of April, we are producing only 12-12-12. So I see that the other two products have 0 quantity. Then there is some coarse that is sent out from the model. And again, some fine NPK that is sent back to a silo. And you have the possibility to recycle this NPK into the process. For the case we are looking at, there is no recycle, the quantity is 0. Regarding the 3 silos that we have here for the product, they are not directly measured. So the inventory of the tank, the final inventory, is automatically calculated by Sigmafine according to the initial inventory and the inputs and the outputs. Let's take, for example, the silo for NPK 12-12-12. Let me zoom it a bit. And let's check some results. Here I can see all the Sigmafine results in a tabular view. And I see that the tank has no measurement for this because the user doesn't have this information available. There is an opening mass of 1,000 tons, and Sigmafine calculates for you the output based on what enters and what goes out. So we said that the first step is to execute the balance of the model to be sure that no material imbalances will badly affect the composition results. This is the reason why we have some difference between what was measured by your meters, by your measurements, and what is the reconciled data in green. The data for this demo were taken from the balance analysis. So we are looking at a model where two Sigmafine analyses are executed. And then the reconciled data is read as input into the material tracking analysis. So let me show you some of the results that we prepared for this demo. During this case, the 29th of April, we are producing, let's say, the standard formulation for 12-12-12 NPK. So if we see, the ammonia and the solution have this quantity. For the ammonia, 100 tons, and for the solution, 50 tons. The result of the material tracking here is to provide the material composition of the flow and to track it till the end of the model. This means that the flow that I'm selecting here, which is the output of the granulator, is made of NPK, so the material is NPK, but there is a material composition that provides me for the total mass, which is 2,000 tons, which is the composition of the raw material used to produce this NPK product. If I move to the second case, the next day, I see that again, we are producing the 12-12-12 product, but the formulation of raw material, the quantity has changed because we are using less ammonia. Before it was 100, now is 70 tons, and more solution, 100 tons. So if I look at the final composition here, this composition is given and calculated automatically by Sigmafine. And in addition to this, since I'm using less ammonia and more solution, I see that the material tracking is calculating also the cost, because I want the analysis to calculate the final cost of the product. And here is 212 USD per ton. For the 3 consequent cases, the 1st of May, for example, we are changing the production. We are producing now the 5-20-20 formulation. You see that the 12-12-12 is now equal to 0. And again, I can compare the cost and the composition of this product. You see here, there is no ammonium sulfate in the raw materials. This means that the formulation, the composition for the 5-20-20 is not containing the ammonium sulfate. And if we want to check, I see that the ammonium sulfate that was used here is 0. So this is reflected in the final composition of the product. Finally, I move back to the last case where we are producing another formulation, the 17-17-17. And this is produced using some fine recycle. So after the screen process, some fine is recycled back and sent into a silo. And from this silo, there is a recycle of 3,000 tons that is processed again to produce the 17-17-17. In this case, if I check the material composition of the NPK produced, I see that there is, again, ammonium sulfate. In this case, the ammonium sulfate that is contained here in the NPK formulation is not coming from the raw material itself, because I see that the quantity is 0, but is coming from the recycle because it was containing originally some ammonium sulfate. So if I check this information, I select the recycle flow, and I see, let me refresh the data, that here there is some ammonium phosphate. This means that the recycle has material NPK fine, but the analysis is capable to track the raw material composition till the end of the product. So I hope you enjoyed this demo. Now I pass back to Felicia.
So Elena showed you, let's say, the buttons in Sigmafine and a brief introduction on how Sigmafine is able to track your materials as they pass through your process. That's probably nice for the engineers in the room, but perhaps you're a manager or you need to make you're in planning, you are from operations, and you need numbers. So let's look at some reports. We only had 5 cases, but let's say we know it's a week. We're running the plant. This is a Monday to Friday results, let's say. And the plan was to make 12, 12, 12, 5, 20, 20, and 17, 17, 17. So this is the goal. And let's see what the results look like. So on the first 2 days, we made the material as per the recipe. And as Elena showed you in the demo, the operations decided to tweak the recipe a little bit, maybe because they had a buildup of inventory on some recycled solution, but the grade was made, let's say. So that's a good job. Then we move on to making some 2025, 2020. And here we see that the recipe was maintained, no changes were made. There are small changes between the recipe and the balance numbers. Elena mentioned that Sigmafine does do a mass balance reconciliation to ensure that the data is good quality. So everything is according to plan. You can see in a click of a button. You can also look at the 1717. Here, quickly you see you have 2 new materials in the pink and the light blue, where we are using phosphoric acid and ammonium nitrate for whatever reason. The plant has changed the source of some of the P and some of the N, and you can see what materials are being used to make your products. Another important number is not just the composition based on raw material, but what is the unit cost of your product. You're selling your NPK something, I don't know, between $350 and $450 a ton. So you want to have a good margin. So you're doing pretty okay from my point of view. And you can see you're always below your selling price, which of course you need to be, but you do have some variation as you change your recipe, as you change your raw materials, as you change, etc. So in a nutshell, somebody can see this is 5 days of work in 2 graphs. This is on your product side. If you look on your inventory side, you have not everything you use goes out in the first pass. We know you have a recycle. Your recycle load can vary from 1 to 1. When you were making the NPK 12, 12, and 5, 20, 20, we're in the 1-to-1 ratio. We are accumulating a fines product, let's say intermediate. And in the 17, 17, 17, in this recipe calls to reuse some of these fines. So you can see here that you're finally reducing your inventory. So you're turning some of your fines into product. And when you do your daily accounting, you always need to talk about your costs. So you can see that your cost, your raw material value was increasing in time when you were making the recipes that did not call for a recycle flow. And so you are moving from $500,000 to 700,000 USD of stored value. So this is not a number you can neglect on your balance sheet. So here we show you very quickly that the material tracking along with the mass balance is able to follow your process, to account the cost as in your product as well as in your inventory. But let's focus on what we learned. It's not magic. What we need is a balance. We need a model. We need a structure. When you give us a structure, when we talk with you and we get a structure, and we apply our algorithm, which is the tracking algorithm, we are able to allocate costs, allocate material on your raw materials, on your products, and on your inventories. And we showed very briefly that this data doesn't have to stay in the, let's say, in the hands of the engineers or the accountant, the production accountant. It can go to dashboarding. It can be made very presentable and consumable by managers, planners, etc., purchasing department. So thank you very much for listening, and this brings us to the end of our webinar from myself and Elena.
Thank you for this great presentation, Felicia and Elena. We have a few questions queued up. First question is, how and who selects the mixing model?
So this is a configuration. I can show you briefly. So each of these symbols represents an asset that is stored in a database, and you can configure it. So you decide per each asset which is the mixing model in a dedicated attribute. So there is a mixing model attribute here, and you define, depending on which type of tank we are looking at, you define the logic. It depends on the process, it depends on the fluid that enters, and the structure of the tank itself.
Are you using dynamic data reconciliation to determine material movements?
Yes, we are using a data reconciliation algorithm for solve the material imbalances. And also, in this case, if you have material movements, also the material movements quantity will be reconciled in order to satisfy the balance equation.
Can the inventory be seen in terms of products?
Yes. In this case, we show you with the demo the inventory in terms of raw materials, but it's possible to you choose which element, which material to track. So in this case, we are saying that the fine is made of raw materials. But for example, you can decide, depending on which material enters, you can decide to specify the product composition. So the percentage of 12, 12, 12 inside the tank, or the percentage of 5, 20, 20 inside the tank. So yes, it's totally configurable.
Energy is an important part of cost. Do you account for this in the model?
For this model, we are using the cost per material. So it's a parameter that is defined by default and in a table. So we associate per each material a cost. This cost can be or the pure cost material, or you can also include a part of energy in this.
We also have, Elena, we're not showing energy today, but we have in the Sigmafine infrastructure, there is also the energy balance option.
Yeah.
Okay, so we can do linear energy, we can do we can do the energy balance, we can do mass and energy. So it is we've done utility networks. Let's say for the process, when you have the Sigmafine infrastructure, you can have, let's say, the mass and composition, mass and material tracking on your process side, and then you can have your mass and energy on your utility side, for example.
How are the qualities of raw material and products analyzed, online or offline, with feedback to correct the model?
This is a little bit tricky here. Let's say Sigmafine is in this context is tracking. So we are using the data that you provide, whether it is in a table, whether it's, in this case, we are using a table. If you missed our first webinar on quality tracking, we were using data from analyzers to track the qualities of the material. So that question is more related to quality tracking. In quality tracking, we're tracking chemical and physical properties of the material. And this data can be collected, let's say, near real time. It can be last available, the average of the day, etc., etc. It can become, and in the case it is absent, we estimate it. And when you have it available, it's a correction. So your measured value is always your, let's say, your reference data. In the case of material tracking, we are tracking properties. So we are tracking business properties. In some, let's say, if you want to consider density as a tracking, it is still being inferred from a data table, from a material data sheet. So you have to think of material tracking as a business algorithm that is following your process. It can be following the material source, the supplier, etc., etc. It is not with analyzers.
In which sense did you mention digital twin in the webinar title?
Without, I take the liberty to answer this question because if we didn't talk about your digital twin, there is no way we can track your material. Without knowing how many inventory points you have. We need to know, basically, we need to have a copycat of what you have of your materials moving in your facility. And if we don't start with a model, if we don't start with how the assets are arranged and how the materials are moving, we are not able to track anything. And we think this is one layer in your digital twin. Your digital twin will have, of course, control loops. It will have many layers, and material tracking and, let's say, mass balancing, which will be your next webinar, should be layers in your digital twin. You will also have health and safety issues and electronic logbooks. We just say that the tracking of your materials, the balancing of your mass, your energy, your volumes, and tracking your qualities should be layers that add value to your digital twin.
Felicia and Elena, on behalf of all the participants in PIMSoft, we thank you for taking the time to participate in our webinar and share your knowledge. Anyone interested to continue in this discussion on material tracking can contact Felicia or Elena directly at the emails provided. We thank you all for attending. Once again, we'd like to thank Felicia and Elena for their time putting this presentation together. We hope to see you at one of our next webinars coming up. We thank you for attending.